Good morning, good afternoon, good evening, wherever you are, and welcome to another episode of The Ways We Move. I am your host, Nicholas Zard, and today, we have an interesting company, and I'm really excited about this company because years ago I heard about what they were trying to do, a flying car. Now, for those of you who have been following our news, following, The Ways We Move, Electric Air Mobility News. When it comes to flying cars, there really are only three, four, maybe five companies making real flying cars. The rest of it, it's a term that we use. It's a generic term, as well as air taxis. Well, there really are not taxis, and they're really not driving and flying, okay? But this one is actually one of the closest one that comes to a flying car. Now, it's more flying than a car. It doesn't really have wheels, or perhaps it does. Actually, I forgot to ask that stupid and silly question, but we'll find out very soon because I'm going to introduce to you Carlos Salaf and Pete Betar from Leo Flight, who unveiled their solo concept this year at CES 2025. Take it away, guys. Great. Well, Carlos, Pete, please introduce yourselves. Tell us a little bit about who you are and your background, and this thing called Leo Flight.
Yeah, thank you. Yeah, Pete, you want to take it away?
Sure. Thank you for having us, Nick. This has been an adventure, to say the least, for the last 4.5 years since Carlos and I met, right in the middle of the pandemic, soon after the Go Fly competition, which was an international competition sponsored by Boeing back in 2017 through 2020. We did a competition which was a single person vertical takeoff and landing aircraft. And I actually came in second place in that whole thing, was able to do a lot with very little. And Carlos saw that and reached out to me, just kind of cold called me, and we hit it off right away with his vision for what a flying car should be, using potentially my propulsion at the time. And then that sort of evolved, and we've become very close, good friends since then. Leo Flight is building the world's first practical flying car that actually looks and feels like a car and fits in a two-car garage with another car, which is exciting. And that's all possible because of our radical new propulsion system and technology using clustered electric jets. And clustered electric jets allow us to basically fly vertically with very little weight for the propulsion system, and then transition to forward flight without articulating anything. And it allows us to basically fit in a sort of car-sized and automotive footprint because the world is built around cars. It's not built around helicopters, which most of our competitors basically are. Electric helicopters, multicopters using open blades and things like that are dangerous and that do not fit really within the world's current infrastructure. And everywhere around the world is basically built around the automobile. So you have everything from homes to garages to parking lots to roads to, just standard infrastructure of city streets and urban environments. It's all built around the automobile. So if you can build something that flies and takes the automotive footprint into the third dimension, now you have something that really changes the world, and it changes the way people move, and it actually contributes toward human evolution because we become less about being one and two dimensional people and more about being a three-dimensional person. And that even just that mindset, intellectually, mentally, for each individual, when you start seeing the world in three dimensions in terms of how you can travel, that actually changes the human psyche. And we're excited about the ability to bring technology to a point where democratization of the skies becomes possible. And we are at the cusp of doing exactly that.
You brought a lot of great points, and we're definitely going to come back on your propulsion system because that is very unique. I've only heard of one other person who talked about that in the industry. It makes me wonder why. But let's also hear from Carlos about how. Well, we kind of know how you guys got to know each other, but tell us a little bit more about your background, Carlos, too.
Sure. Yeah, no, Pete gave an excellent overview, and kind of coming from my side of the equation, I'm Pete's co-founder. We started formally in 2021. Before that, I had worked in the auto industry for since 2003 as an automotive designer. I worked at Mazda's advanced concept design studio, where we worked on both concept cars and production cars. After that, I went on to do my own bespoke car design. Uh, I wanted to kind of create my own. I wanted to create my own car design, and
Of
that's
course.
still something I do more as, I guess, an enjoyable hobby almost, because I see where cars are going at large, and we're going
Yes.
toward the Zoox autonomous car model, and so what I do is more like gearhead stuff and um, for fun.
Yes.
But bringing that automotive mindset to the equation, Pete was doing really interesting things with eVTOL for a long time, and when I first heard about Pete during that GoFly competition, I just couldn't believe that one man had created all of these different eVTOL machines, both gasoline powered and electric powered, and then had realized, wow, I could downsize this propulsion with small electric jets and starting to cluster them. And I thought that's the ticket, because I had been kind of thinking for a while about coming from the automotive world and seeing what was going on in the eVTOL space and AAM. Like, why can't we take more of the thinking behind automobiles and transfer that into air mobility? And what the propulsion side of the equation that Pete was already addressing was really apparent to me. And I reached out, and immediately we hit it off with this vision that Pete just described for personal mobility.
Yeah, you said it very well, and I think we'll have a lot of great discussions about the automotive world. Great. So yeah, let's talk a little bit about. Oh, first, before we get into the technology part, the question I've been wondering, because guess what? I've actually been following you guys since even back then in the Boeing days. I was already covering this for, I can't remember who I was covering it for, but anyway, I remember seeing what you guys were doing. I remember seeing that something that really interested me. You said exactly what you said now, a real flying car that actually parks in a parking space of a real car. Now, this is something as a journalist that always horrifies me is when I hear air taxis and flying cars. Let's face it, there are only 5 or 4 companies making flying cars per se. And when it comes to air taxis, it's not an air taxi. I'm going to a place to fly. It's the opposite of a taxi that I just hail like this. So I was always very impressed with what you guys are doing. But the one question I still don't have the answer to is why Leo flight?
Yeah, well, something I want to put a little bit of a point on what you just said too. The way that we see where most of the air mobility industry is kind of getting behind this air taxi model, as it's called. We look at that and we feel like, okay, that's more of a shuttle bus in a terminal. You fly from an airport to a terminal, and then you have to hop into an Uber or a scooter, and this multimodal idea, and go somewhere else. That's what that is. And what we are after is really truly creating a passenger car of the future, truly creating a passenger car of the air, where you can, leave your house, open the door like you would a car, jump in, and fly to your destination. And a lot of times when people hear that, they're like, oh, that's pie in the sky and will never happen. But a lot of people would be surprised in how reachable that is. And so that's where we're
Mhm.
putting our energy. But why Leo flight? Well, Pete and I are both Leos, and our birthdays are very close together, and you are as well, Nicholas. But it just sort of felt right somehow, like the simplicity of the 3 letters, its connection to the constellation, the idea of looking up. Something just felt really fresh about it and felt right about it. And after not too much deliberation, it was like, yeah, it feels right.
I hear you. Yeah, when the name sounds right and you feel it and you get it, and you're right. I mean, everybody remembers Leo Flight, and so I'm glad you've answered that one because it's true that you guys are the only like real. You know what? When I watch Blade Runner, that's what I see. I see Leo Flight. It's
Mhm.
exactly that, right? That's exactly what I envisaged.
That's a high
Um,
compliment.
Yeah, but it is.
Yeah.
I mean, that's what I have in my head when I do that. And also another thing too is when we design multi-ports, right? Where we want to work with airplanes, helicopters, and of course eVTOLs, but also eSTOLs, eCTOLs. One of the things that we do is in the parking lot, we want to make sure that EVs can go there and recharge, that AVs, autonomous vehicles, can go right to the terminal, yada yada yada. But it's right. In about 10 years from now, by the way, even less, I also want to see people being able to land with their own personal flying cars and hop onto a bigger one, then go to a Verta hub or multi-hub port, whatever, and then, I don't know, catch a big 787, A380, who cares, whatever, an electric boat, a space rocket, thank you, Elon, one of these days, right? That kind of stuff. Yeah, fine. And so you're right. You're adding one piece of the puzzle. You also said another thing too that will lead to the next question is, yeah, technology is not the problem, right? Certifications are, and that's a good thing to have. It's a good problem to have. But in 2019, I was in Guangzhou, and EHang was already flying passengers back and forth between on the both sides of the river. So when you
Mhm.
tell people that, they're like, "Oh, really?" It's like, "Yeah, absolutely, absolutely." So let's talk about the propulsion system because that's really what makes your project so unique and so compact, I guess, in many ways. Tell us a
Mhm.
little bit more about it. Why not open propellers? Why not just or duct fan propellers? I mean, your situation is very unique out there.
Yeah, I can handle that. So this is one of our propulsors. Um, it's 120 millimeter interior diameter, and it weighs about a pound and a quarter, roughly. It's very light,
Wow,
um,
wow.
and it produces up to 20 pounds of thrust. You know, not now that doesn't include its battery weight and so on, but roughly another half a pound of electronics that are drivers for it, and then you've got your battery weight. And the thing is, vertical takeoff and landing um, is a very small part
Yes.
of the cycle of the flight cycle. So unless you're hovering to take pictures, which is you can do that with a drone, but unless you're just specifically meant to just hover and hang in space, the point is to get to your
Yeah.
destination, right? So if you can take off vertically and
Yes.
transition to forward flight within 45 seconds, you're really not using this very long in vertical
Nope.
mode.
Nope.
Um, electric jets are about 60% as efficient in terms of endurance with batteries than props are. So if you want to take pictures, like we build a jet drone using these actually, and that drone is great for covering distance. It's not great for just hanging and taking pictures. So we recommend different drones. We also make some drones in my shop for using propellers, and they can stay in the air for an hour, and just take pictures, do surveillance, whatever. But they're slow.
Yep.
They'll go
Yep.
45, 50 miles an hour, but they're slow.
Right.
Um, the point of using electric jets, though, is that
Yes.
they become much more efficient in forward flight and covering distance per charge. So I could maybe only let's say I had a standard battery, um, an electric jet, like a big car size electric jet, um, could maybe only stay afloat or up for uh, you know 10 or 15 minutes. But in forward flight, I can go much further because I can, first of all, throttle back, and I can use aerodynamic lift from my wings. But then the other piece of that is I'm covering a lot more distance in less time. So let's say we were apples to apples. I could fly for 45 minutes with a propeller, but only half an hour with a jet. Well,
Right.
that propeller is going to maybe go 100 miles an hour to 120 miles an hour. My jet's going to go 200 miles an hour. So I can cover nearly twice the distance, or at least 60% more distance, but using only about 30% more time, or less time, actually. I'm shaving the time for the same battery. So I can't hover as long, but in that period of shorter time, I'm covering much more distance. And that's the difference. And that's where we went with just a fixed, especially for the Leo Coupe, just a fixed vertical thrust profile, because we're only using it for 45 seconds and then transitioning to forward flight where we're really gaining our advantage. So overall, in terms of going from point A to point B, we're much more efficient than propellers for the total mission profile. And that's why electric jets. The other part of electric jets, and I'll let Carlos do this, is you can do a lot more with design when your propulsors are small. So I can reorganize those propulsors around my design, and I can make literally anything fly. I mean, like, it's in terms of vertical takeoff, at least. I have the ability to put these clusters of small jets together in a way that fits that automotive footprint a lot better. And you really can't do that with propellers. The other side of this is safety. When we were first testing our LX1 propulsion prototype with a person in the cockpit, the person was just sitting there, and I was actually running the controls from the side of the airplane, from the side of the aircraft, standing outside the aircraft. Like, I was right next to the aircraft running the controls because I didn't have any worry about being hit by a propeller. There's no way any of our competitors could do that kind of thing. So it allows for much lower cost of development, much more flexible, access to design features, and then much more efficiency in actual total overall flight profile to get where you're going. That's why clustered jets.
So
and by the
before
way,
Carlos, yeah, and exactly. So that's another thing too. So many things you say there. And Carlos, before we get to you, just two things. First of all, yeah, just to remind our watchers or our listeners is that an eVTOL is not going to take off directly vertical like this and then kind of hover and then go into a horizontal flight. It really will do just like a helicopter. Take off and have a very steep angle of attack, so maybe 45 degrees, something like that, and then transition to. So you guys are really taking a full advantage of that, and without using too much. Now, the other thing I just heard is, where do I sign up to be one of the test pilots? I was like, hang on a second, I want to be in
we
there.
already
I
had
want
you
to
on the
feel
list, Nick. I don't know. We already had you on the list.
Okay, there you go. Because I always thought, I would love to have a Leo flight, a solo, just to be able to go to a party and tell my friends, is your front lawn open right now? And then just land. I mean, can you think about that? The smashing hello, guys, I'm here kind of thing.
Yeah.
That's a
Sorry.
And
flex.
I will say too that the solo, we rotate the front engines only just for that 45-degree climb out. The coupe can actually take off straight up and transition forward. I mean, that was the idea, was to keep the coupe where the coupe did not. I mean, you can maneuver aerodynamically, but if you wanted to stay completely flat your entire flight profile, you could actually keep it completely level, take off vertically, and fly forward. So if you're between buildings or whatever like that, the coupe is really designed for that. The solo is an ultralight aircraft. It's meant to be flown outside of urban environments anyway. So we just thought, that's to lower the cost. We don't need as many thrusters, and we can do this with basically a 45-degree climb out and save a lot of money and make this a much more affordable, aerodynamically based aircraft that has a glide ratio and everything, very slow stall speed, all of that. So that's exciting about the solo. It just makes it a little more accessible, a little less complicated. The coupe is really, but the coupe is exactly the vision of, like, sort of that Blade Runner 2049 concept.
Sorry, I've got my chocolate labs are just decided to bark right now, of course, right? And another thing too that you just mentioned too is the certification roadmap is way easier the way you guys are doing it, both for the solo and the coupe. So yeah, this is brilliant thinking. We'll get to Carlos. I want to have his point of view, and then we'll talk about how you guys thought of all that, because why isn't everybody else doing the same thing, right?
I don't know. I can't really answer that. I mean, it seems really obvious to Pete and I, and so that's why we're doing it. But his technology, this clustered electric jet propulsion, has been so enabling, because if you imagine a mesh of tiny electric jets and how that mesh can form to the aircraft architecture that you need, that gives us a ton of packaging, if you will, flexibility. We've been able to create the contours and the size of aircraft that we want, embed these into the wings of the aircraft. with louvers that close over when it's in forward flight. And so when
Mm.
you don't have just this massive architectural piece that is a massive propeller or even a ducted propeller, it's incredibly liberating.
Yeah, and you're right on the design side. You're right. The flexibility is amazing. You one of the other thing too that I keep on thinking about is you can actually shrink that design down to a one-seater, like a bathtub kind of configuration, to making it a bus at one point or another, because battery technology, energy density,
Mhm.
power density is also shrinking a heck of a lot. So is affordability. We've seen that since the 90s. But your design is pretty amazing. You can shrink it or make it bigger. So that's an amazing roadmap that you guys have
It's very
designed.
scalable. I mean,
Yeah.
and also I think I don't want to lose this in that safety is paramount, because once you've created a safe object that will not hurt someone or damage an object if it touches it,
Yep.
that just opens up so many possibilities in terms of densely populated areas, urban, or whatever, forestry, whatever you're talking about. I mean, Pete's drones, which run on the same technology, can fly right through a tree, and it's just
It's
gonna
not
go
going to do
right through it.
anything. Yep,
Yeah.
exactly. I'm actually thinking of a motorcycle now. Like remember who had a motorcycle? Oh, yeah, it was one of the Google guys had a flying motorcycle, but it would be so much better with your little jet clusters. I mean, you could do a heck of a lot with that. So how did
Yeah,
you guys?
stay tuned.
Stay
Yeah, yeah,
tuned.
exactly, exactly. Oh, okay, can I have a slimmed down version? I want the race version. I want the race version. I want the race version.
It's all on the
How?
table.
I can only imagine. I can only
Think
imagine.
about, yeah, racing is a perfect application.
Yes.
Wheel to
Yeah.
wheel. Okay, in this case, it's like body to body or wing to wing. And it's safe because obviously you don't want things colliding, but if it were to happen, you don't have a propeller striking something and then hurting either the
Shredding
other
it.
person or some an
Yep.
onlooker, or yeah. So
Yep. Yep.
Well, and the other thing, going back to safety, I'll just add this, is that because we're using so many engines, um,
yes,
Yes.
the redundancy factor is really strong. And one of the tricks and one of the biggest challenges we faced with this propulsion was sort of getting each quadrant of engines to see, like the flight controller to see each quadrant as one engine, so that if it's gyroscopically, leveled. So if one engine happened to fail in one quadrant, the other 24 might kick in a little bit extra, a few percent extra thrust to balance it. And you wouldn't even know you lost an engine except for the indicator light. So you could lose engines, the rest of them around them, because you lose, like, if you could even lose up to 25-30% of your engines in one quadrant, and there's enough margin of
Right.
thrust there that the other engines would automatically respond and make up for that to keep the aircraft level. So that's just in vertical flight, of course. But yeah, so I mean, the redundancy
It,
factor is not trivial, and to get to that point was not easy. So why doesn't everybody else do it? It's because it is a difficult technical challenge, and we've
yeah,
done
but
it.
it's interesting. Yeah, and you've done it. It's interesting because it goes back to one of the great selling points of eVTOLs in general, or any kind of distributed propulsion systems, is there's no single point of failure, right? But you guys
Correct.
have gone even granularly below that one, because you're treating an exhaust actually as a cluster of propellers, basically, or cluster of thrust. So that's pretty amazing what you guys are doing there. So it makes it even more redundant down there. And you're right, actually. But I'm thinking now more and more about the speed benefit. I mean, your eVTOL should be one of the most efficient out there when it comes to charging it, when it comes to energy
Mhm.
usage in general,
it
right?
really opens up real inner city travel.
It
So
sure
for
does.
most trips, this will do the trick. If you need to fly very far and fast, jump on the boom supersonic that's coming. But for
Right.
most trips, I mean, this could cover a lot, especially with a charging network to boot.
Yeah,
Yeah.
with our
LA to
Yeah.
San
standard.
Francisco in one charge, for example. Sorry, Pete, go ahead.
Yeah.
No, go ahead. I'm sorry. With our standard battery pack, right now we're able to do. We're projecting 250 miles per charge, but we're actually right now
Wow.
flying drones. Yeah, but we're flying drones right now we're working with a new battery chemistry that is
Yeah.
in production now. We're actually flying this today. In fact, I'll tell you, Carlos, later. We're actually testing with the Amprius cells, And
Yes.
Amazing.
I love Amprius.
we're running 400. We'll be able to run 400 miles with those packs. It'll be a slightly more expensive battery for the
but
users, but
yeah.
400 miles per charge. Like we're totally automotive at that point and beyond.
So that's another thing too I wanted to talk about. I love Amprius. I've
Amazing.
had these guys are absolutely amazing. They're sending out right now in the wild 550 to 600 kilowatt hour cells to be tested. So these guys have already broken the holy grail. We're not quite there yet, but we're only always a few years away from that. There's so many battery technology, battery chemistry options right now. Do you guys feel comfortable talking about what you are using or what you want to use, or maybe just what you're excited about?
Sure. Yeah, we're pretty excited about like right now we're basing everything on a Tesla 2170 pack.
Perfect.
And that's running around 230 roughly watt hours per kilogram.
Nice. That's perfect.
Cells, the Amprius cells we're running right now are 330. And they're moving, and that's like in production. And what we're moving forward is that 500, which would really be like full double. So I mean, we're very excited about the time that we're doing this, because I know Toyota and Samsung both announced that their 500 watt hour per kilogram cells are going into full production like next year, which is perfect timing for the coupe to be in production in 2027. So if we can tap into that, and also the cost of solid state will drop dramatically because it's a lot less expensive to make. You also have greater safety because you can punch bullet holes through the battery and it won't catch fire. So I mean, it's amazing where this is going and how well it fits for the eVTOL application. Plus, the C rate is higher. So one of the issues has always been the discharge rate that your battery charge and discharge, and the C rate is much higher for these solid state cells. So it's exciting. It's very exciting.
It is. It's weight saving. It's more energy per volume and absolutely, and weight. So it's absolutely fantastic what you guys are going into. That's all the things I wanted to hear. I love it. I love it. Tell us a little bit about. I mean, we've been talking for about a good 15 minutes now. Tell us a little bit about your projects ahead, and then I want to talk about the who's behind. Why are you guys doing this? But first, tell us about your roadmap. I mean, do you have anything you want to tease our listeners with? Are we going to see a 900 miles an hour electric jet propulsion system? Elon Musk said we were going to do that, right?
Did he? I don't know.
He did. Yes. He said supersonic
Okay.
Electric flight will happen by 2050. I was like, boy, okay, whatever.
It's possible. I've actually theorized some stuff, but it's gonna take. Well, it's possible.
It could happen. Yeah. You know what? In a lab,
it's not with spinning turbines, though. It's not with conventional air moving.
No.
You're talking about explosively detonated molecular oxygen using lasers to propel. Yeah, and that's possible.
Yeah, exactly. And in a lab, I can make it happen sooner than that, no problem. But no, I don't want to make fun of Elon Musk. That wasn't the point. But just be careful what you hear out there. A lot of people talk. Just be pragmatic. Be down the road.
There's theory, and then there's reality, and that's
exactly. And we got to make that come together, which is what we're talking about right now. So tell us a little bit about your roadmap. So we've got the Solo, we've got the Coupe. I mean, anything else that you're thinking about? You would like to talk about at this stage? Because I mean, there's a lot.
Pete, is there anything else we want to talk about at this stage?
Well, let's see. You want to go for let's go for a walk.
Yeah.
Whoa! All right, cool, man.
So I'm going to show you something that.
Let's see if we still get Wi-Fi. But
if we still get Wi-Fi.
That hangar has.
So this was a project I did for DARPA in 2022 and 23. So
I was thinking of that, a wing.
This is it's actually an electric jetpack. And it uses the same clustered electric jets. This has been, unfortunately, I had this in a museum for a while, and they ran out of space in the museum and had it setting outside for some period of time. And so the engine housings out here kind of rusted, but otherwise this thing is functional. And we're planning on rebuilding this in all carbon. This was done in aluminum, very heavy by comparison. So we can do this in all carbon and probably cut the weight in half. But
And
Yeah,
Pete,
especially
just to
with
let you know, I've got a lot of space here, so don't worry about space, okay?
yeah. So I mean, we're excited about what's possible in terms of like
Wow.
wearable human flight. We're
Yep.
also looking at a like a hoverboard kind of a thing. So we'll see if we can come up with some little side projects that might have some special use applications for first responder, military,
Yep.
crazy people, stuff like
Yep.
that. So we'll
Yep.
see.
Crazy people.
Yeah,
Yeah.
crazy people. You know what? It's funny because that's one of the things that I was thinking is you can really shrink that down. Like you said, it's very scalable, but you can shrink it down to, you're right, like a jetpack. It's just such a given for that.
Yeah.
Oh man, I could do my
Yeah. And
Yeah,
we're
groceries.
Pete's
talking
been flying these. Pete's
with
been flying
Amprius
these at
batteries.
subscale forever, and then
Yeah, with Amprius
man,
batteries, we could do probably 9 to 10 minutes of flight time, at 100 miles an hour. I mean, that's no joke.
But you know what? For someone like
All
me who
wearable.
always forgets something when I come back from shopping groceries or something, like it'll be like, hang on, I'll be right back. Click.
yeah,
Poof.
boom.
I love that. My wife will be like, oh, okay, he did it on purpose. Of course I did it on purpose. What do you think?
Yeah, well, and I mean, the beauty is we can actually fly that. You don't need to be an X Games athlete to fly a jetpack like that. It can all be made to fly like a drone. It's all fully potentially autonomous or at least semi-autonomous where you
Yes.
just tell it where to go. Yeah, so
Yeah.
it's got that self-stabilizing capability that makes it
Yeah.
really, really nice.
Yeah, we don't want to let people do too many things. I mean, some people do some very strange things these days, common sense kind of thing. So,
Right.
tell me a little bit about, I mean, why in the world are you guys doing this? Why don't you just get a normal job, get a house, get cars and vote and just be quiet? I mean, what the heck is wrong with you guys, right?
Uh, YOLO, I guess. I mean,
Yeah.
I mean, why not do something fun with our time? I mean, of course, there's risk involved, but I don't know. I feel like personally, and I think Pete is a bit like me. If there's not some risk involved and
Yeah.
something on the line, but also some really big reward possibly on the other side. I mean, that just makes life a lot more exciting. Not to mention, we just love the joy of making cool things and making exciting things that could change how we move and make things more efficient and move more quickly. And
Yeah.
it's some of it's just the simple joy of flight, and
Yeah.
Mhm.
like Pete's a pilot. I traveled a lot as a kid and kind of fell in love with flight and went into car design and stuff, but I always kind of wanted to come back to it because it's just
Yeah.
magical. It's just magical just
It is.
as a human being to experience flight. So
It is. It
it's
is.
fun.
Yeah. I think purpose too, for me, it's always about purpose. Like purpose is what wakes you up in the morning. If you're living your life toward a, a noble purpose and something that can help your fellow human beings, in a meaningful way. Like, our drones right now, we're flying some of these drones in Ukraine to knock out the Shahed drones that are attacking Kyiv and destroying infrastructure and killing people. I mean, if we can save lives with this
Yeah.
technology, and we have the ability to do it and a unique ability to do it, then that starts moving from even beyond purpose to calling. And if you are gifted with the ability to help people in a unique way, then I think you have a responsibility to do something with that.
Oh,
And I
yes.
think there's, we live in a world that if the world were built around flying cars instead of automotive road cars, just imagine how that would look. And what if in 100 years you could get 20% of the people in the world to fly to work every day instead of drive,
Yep.
or instead of walk, or instead of propel themselves on the ground in some way? What would that make the world look like, and what would that do in terms of infrastructure and opening things up? And you talk about cars burning gasoline and what that does for carbon footprint, but think about making and maintaining roads. Like that's not nothing. There's so much to just the things we take for granted in terms of infrastructure that if you can get
Yep.
away from some of that,
Yep.
it really changes things. And there's a lot of people right now working in the space for batteries, and I think that technology will continually move away from lithium and
Yeah.
difficult
Of course.
environmental impact kinds of materials and move toward more common things that are more recyclable and whatnot. I think that's going to happen. I think you're going to get greater energy densities. I know they're working on like fluoride batteries with 8x the
Yes.
energy density. I mean, those kinds of things that
Yep.
are inexpensive, that are environmentally friendly, that are generally a lot easier to deal with in terms of infrastructure and the energy that it takes to make something. And we're just taking advantage of, and it's a collective effort. So we're taking advantage of technologies and putting together to make a flying car. Yes. And that's cool. And we're kind of maybe the sexy point of the spear, but everything behind that, without all of that, it's impossible for us to do what we do. So that's why I say, there's a bit of a calling, a responsibility, a purpose-driven life that you have to have. I think in this world today, in order to make the future better for our kids, hopefully that's going to happen.
Yeah, no, and you're right. I think, and you're definitely part of that trend. And you said something that was really interesting. Is that's what got me into this field 20 years ago is efficiency. When you think about it, a gasoline car, a third of the gasoline tank gets the car to move, right? So 2/3 is lost in heat and friction. On top of which we're using rubber wheels on tar. I mean, come on, that's a lot of inefficiency. An EV, even though it does use rubber wheels and it's on tar, but I mean, at least it's 80 to 90% effective, and 80 to 90% of that battery pack makes you move. And something that I've heard, and it still drives me crazy, is a lot of people think that flying is not efficient, and I'm like, I beg to differ. It's way more efficient than riding a car again with rubber wheels on tar. It's super efficient, and after that, I mean, it's really it's metallic wheels on rails, and that's about it. So no, you guys are doing a great job, and I've certainly enjoyed having you on the ways we've moved. You are definitely architects of the future, and you fit very well with the ways we move. And I really look forward to having you guys back on again, because there are a lot of things we need to talk about. Any final words you want to say out there for people listening to you, people who might not know who you are? We'll make sure to have your information not only here but also on an article and everything. But any final words for our listeners and watchers?
Carlos,
Thanks for having us. And I love your glasses. It took me a second to realize, like I was really proud of myself that I noticed the asymmetry there.
See, the designer will notice this. Sometimes I feel very square, and
It's
sometimes
very
I feel like a
playful,
very rounded. Yeah, I got a red
like you.
pair, I got an orange pair. Yeah, it's just like me.
Playful
My
like
poor
you.
wife. Yep. Thanks.
Yeah, no, I mean, for me, I appreciate the opportunity to be here and um, to make people's acquaintance, and just stay
Yep.
tuned. And um, that's about it for me. What about you, Pete?
Yeah, I mean, stay tuned is exactly right. Like we're really doing things. We've actually flown, our propulsion prototypes with a person in it. We're doing a lot with very, very little resources, but it's incredibly cool, and we're going to have some mic drop moments in the next year or so. So just stay tuned.
Yeah. We're hoping, for those of you who are still watching and listening to us, we're working on some really interesting projects, some really cool projects, and I can't wait to have these guys back on again, because you're one of the rare companies that is self-funded, for one thing, and enough to have a sustainable business model. Because we always talk about green sustainability, but a sustainable business model is the most important thing you need to have. And there's so many other things too that I look forward to having you guys back on this podcast so we can talk about the rest of the many things we need to talk about. So in the meantime, we hope you've enjoyed this. Stay tuned for more.